Let's talk VDML with KJR.
Okay, well, welcome back to another episode of Let's Talk VDML, and I've got with me today Andrew Hammond and Aaron Bell. How's your day going, guys?
Yeah, no complaints.
Keen.
So, and as we've been, talking about in previous episodes, we're talking about validation-driven machine learning and thinking about how do we actually, approach AI as a trusted tool, and how do we build trust and confidence in AI. So what we wanted to dig into, and the specific reason why I got you guys here for this episode, is having a look at the very starting point of thinking about an AI project is identifying what's the task, what are we trying to actually apply AI to, and then what are the risks associated with that, because that context is going to then drive a whole lot of our follow-on activity in terms of how we build trust and so on. So maybe if you guys want to tell us a little bit about what you've been doing. It's pretty interesting stuff in terms of applying AI to novel kind of problem.
Yeah, sure. So I think the first thing to think about is that when we talk about AI and understanding the problem and defining the task, it's from that the risks lie in the consequences of performing that task, be that through making a bad decision because of some kind of AI or machine learning, but it also exists in terms of things like collecting the data, etc. So it's really, really important to understand the context of the problem, be that from a business perspective, but also understanding why it is that you're trying to work out, the answer to a problem, why you're actually out there in the first place. So what we're doing at the moment, we've got a couple of interesting projects. Feral AI is one that we'll refer to today. That's all about detecting both animals, for starters, mainly feral, but it can also be used, the same logic can be used to find native wildlife and fauna. We've also got a couple of other interesting projects. Another one we might talk about a bit today is what we're calling the Marine Debris Task Force. That's about finding debris up in the Torres Strait.
Cool. And I guess for me, often, the starting point, you say, what are you going to use AI for? And people will give you an answer. We're tracking feral animals, or we're looking for, debris in the ocean, rubbish in the ocean. I always find it super useful to then try and articulate, well, what's the benefit of applying AI to that problem, and who is the beneficiary? Like, what's the good that's going to come out of it?
Yeah, well, in terms of I can talk about the feral AI one. And a specific use case that we were engaged to help out with a local council who have a large area of land to manage, and they thought they had a rabbit problem. And obviously rabbits, introduced species, they compete with the native species for food, and they also do lots of damage if they're left unchecked. And so the council engaged a pest control company to come in and assess the amount of rabbits they had, and therefore assess the size of the problem that the rabbits were causing. And the reason that they engaged us and Feral AI is that most of the time the accepted method at the moment is called a meander. And so you get two people in a vehicle driving through the area with spotlights at 15 k's an hour, counting the number of animals that they see and recording them down literally with pen and paper, which there's nothing wrong with that. Pen and paper is it's almost an ageless approach, but the trouble is that you've got a spotlight that's pretty narrow, and then you need the person to identify it and record it correctly. And the problem with that is humans are prone to making mistakes. You might have recorded a rabbit, it could have been a kangaroo or vice versa. And so what you have there is a built-in, well, not built-in, but you end up with an inaccurate count, and then the control mechanisms based on that count then get applied. So if you've got an inaccurate count, your control measures that you're going to put in for these animals are then is going to be limited or inaccurate, and you're not going to get the result. And the result that you want in this particular one was the rabbit problem is they wanted to control the number of rabbits, and if you don't have an accurate number, then how do you control it? Interestingly, the way we approached that was to use drones and some thermal imaging to capture the animals moving around at night. And what we found is that actually they didn't have a rabbit problem at all. I think we counted 4 rabbits in 3 nights, which is, that's where there was more people than rabbits, just to put that in perspective, right? So, but what we did find was in those counts, there was, I think, so across 3 nights that we were out, there was approximately 250 deer that we spotted, so about 70 each night. And obviously deer are much bigger than rabbits and have a lot more ecological, or do a lot more ecological damage. And so that what we thought was a problem with rabbits has actually turned out to be less of a problem. And the actual problem is that there's too many deer because, again, they're an introduced species. So just sort of circling back, well, why is AI involved in that? Well, when we were out doing the data collection, similar to the meander approach, we were out for approximately 8 hours a night surveying this area. And so, 3 nights is 24 hours. There's 24 hours worth of video data to then collect. Get the lights back on. That we collected, and then someone needs to watch that because we weren't doing the analysis in real time. So as opposed to the driving around the ute with marking stuff down, we were capturing the video and then analyzing it later. So where does the AI come in? Well, it's actually to make that task more accurate for one, but also more time efficient for a second point. So that's sort of, that's why it exists.
I think there was a couple of really good learnings out of that one too. So bringing it down to the VDML, firstly is defining that task. So we went out there, and the task we were given was to go and count rabbits. But if you really pull it apart, actually what they wanted to know was what is the state of their biobank, and they thought they had a rabbit problem, but really they were interested in what is the state of it? Are there any feral animals present, etc.? So if we'd just blindly gone through and said, oh no, there are only 4 rabbits, it's all good, we wouldn't have solved the problem that they were looking for. So understanding the context of the problem is really, really important. And then that also gives you, when you're talking about risk, so okay, well that would have been, a certain error where we would have had a bias for rabbits, when in reality, the model needs to be looking at all things. And then I think there's another really interesting learning out of that one, which is if we're thinking about error and acceptability and validation of a model, the spotlighting method, a human, you're getting exactly that. You're getting a very tunnel view or a spotlighted view of the animals that are out there. By using the AI, we're able to search a much, much larger area. So if the tolerance of failure is put too high because it's an AI model, we're holding it to 1 by 10 to the -6 sort of stuff, 5 nines or something like that. It's not reasonable. If you think about the context of the problem, well, the human would probably only see little snippets of the whole environment and maybe see 5 or 6, 10, 20 animals, whereby the drone might find 200 or 300. And if it makes, or if we have an error rate of 1 or 2%, well, that could be quite a lot of animals. But the reality of it is we're getting a much better picture than what a human could do by itself. So understanding the task is really important.
Yeah. So having a, if you like, an understanding of baseline competence, what a human could do, versus what you can do with an AI-based approach. I guess the next thing that I'm interested in when it comes to this sort of like risk assessment or impact assessment, so we're starting to get an understanding. It's not just about tracking specific kind of feral animal as much as it might be, as you say, Aaron, understanding what's happening in the biosphere, so that it can be well managed and we can do appropriate intervention for the benefit of native species, or also just vegetation and so forth, prevent erosion, all those kinds of things that might be being caused by introduced species or that biosphere being out of balance in some shape or form. So we can start to understand maybe what the benefit is, both to us as humans, but potentially also just directly the beneficiaries could be other animals or plants, etc., and the landscape. But I'm interested in how is the AI component of this solution actually being used? Like what decisions are being made? And one of the things that is a key again in the validation driven machine learning approach and in this sort of risk assessment piece or AI impact assessment piece is understanding sort of, is this if you like, an operational AI component, like something that's helping us to make decisions in real time, where there's the AI is contributing to an active decision right now? Or is it more of an analytical piece where it's being used to analyze data, and then you can sort of make a perhaps completely human-led decision-making process about what action to take? And those are often sort of contrasting ends of the spectrum.
I mean, there's a bit to unpack there. So, we talk about risk and benefit. So from the risk analysis process or the assess the risk process, you firstly, okay, why are we here? What are we trying to achieve? That's important. Then from there, you've got to look at all of the different kinds of risk. And you also then mentioned about, operational or non-operational, or that's the same as saying a live and post-processing model, something like that. So on the risk piece, you've got to look at it from a lot of different angles, and you also want to be able to think of it in terms of, I look at risk, which is a fairly traditional way, in terms of what's the hazard, what could go wrong, and then what's the likelihood of that going wrong, and what's the consequence of that going wrong. So that gives you an idea of the scale of the risk. And then you need to consider that in terms of, is there an environmental impact of that thing going wrong? Is there a reputational or a safety one? Is it a psychological? So if the AI gets it wrong, is it a psychological or could be a privacy issue? You can also have financial risks, political risks, etc. From there, you've got to then look at, well, what treatments and mitigations you can apply, and then look at what is it going to cost to actually put those mitigations in place. So again, you come back to what is the benefit and what is the cost, and that sort of gives you an idea of the acceptability in terms of your risk. You mentioned live / operational, and then the non-operational or the post-processing historical data analysis. Just because one's live doesn't mean it carries a higher risk, and simultaneously, just because it's post-processing doesn't mean it carries a low risk. So a live information could be, public transport or something like that, or okay, the bus didn't arrive when you said it would. I mean, it's a live system, but the consequence of that going wrong are pretty low. On the other hand, on a post-processing or a non-operational perspective, if you're making big decisions based on historical or post-process analysis, then you actually are bringing in quite a high risk or a high consequence because you've got an error in your system. So for us, the feral AI can be a bit of both. So the example that we just talked about, it was about giving an idea of population hotspots and what's the state of the biobank, and that is what we would call a non-operational analysis. So we can take the footage, you can review it in slow time and make an analysis. I'll let Drew cover off anything else he thinks on that one, but I haven't covered off how the same project could also have some live operational aspects to it as well.
Yeah, no, definitely. I think we agree with that in terms of the population being the key outcome, but I think in terms of the live outcome, the not that we did it in this particular example, so that's probably important to state up front, but what we could do based on the approach that we had and what our colleagues in the pest management space have asked is possible, is to then actually, while we're out there doing the surveys, if we're running the AI model live on the drone feed, we can then pass targeting information across to those guys to say, well, actually, from where we are now, there's a big pocket of feral animals in 500 meters to our west or north or whatever that is, and they can then use that as to help them with whatever process they're doing. So that could be, again, in that operational area. And I think that the context of that would change quite, because if we're then passing information to say, well, there is a feral animal 500 meters to our west, and they then go and enact some pest control measures, whatever they may be, if we haven't got that identification correct, then the outcome could be catastrophic to the animal. And if it's a non-pest animal, then that would not be great. If it's a pest, then maybe the outcome's the same. But I think that, again, that sort of risk, as Aaron outlined, is if we're not passing the right information or enough information to whomever is going to enact that information, then the consequences of that can be could be catastrophic.
Yeah. That's a really good point on the context as well. So on an operational model like that, again, it's really important to understand that task and the context. So, the immediate problem that you present yourself with, and it's easy to gravitate down this track, is that, if the model has identified or misidentified an animal and it's classified as a feral species when it's a native, then everyone runs around with their hair on fire, like, oh, that's a really, really, really bad error. Well, but if you understand the context of the situation, it's like, well, the drone and the AI is not carrying out the eradication. So as long as people understand the process, and that includes everybody in the system, if the drone or the system misidentifies, let's say it's a wallaroo or a wallaby or something that's protected, and says that it's a feral pig, well, a pest controller is still a human in the loop there, and so that the consequence of that error is a lot lower. If it was an automated eradication program, then the consequence of that failure would be a lot higher.
Yeah. And I think, one of the things that we're seeing come through quite strongly in terms of AI ethics is really as much as possible, the avoidance of situations where, there isn't a human in the loop. So particularly where there's any kind of critical decision making going on. So, yeah, I think, one of the other things that this sort of leads us pretty naturally into is obviously, unpacking that whole topic of AI ethics, and certainly the framework that we follow as part of VDML is looking at ethics in sort of 5 different categories. So we've already talked a little bit about community benefit. So who's getting the benefit, and sort of the flip side of the benefit is that the system should do no harm. So the concepts that we're talking about, we're really trying to minimize the harm that can come from an unbalanced ecosystem that's got feral animals in a unbalanced population. So we're trying to do harm minimization there, but obviously needs to be done in a way that actually delivers benefit, as intended. So you wouldn't want to be enacting a system that was then going to cause other kinds of harm to other animals or to the environment. Other aspects of the ethics include things like fairness. So it probably might seem a little trivial compared to other problems that we have with fairness in AI, but yeah, if the detection model was actually biased, like towards detecting rabbits and saw, everything as a rabbit, or more things as rabbits than it should, then that would be an example in this case of bias and fairness.
Well, and I think there's just to linger on that point, Mark, is an excellent point too, because what we found when we were training the model is the first area that we had to survey was actually full of rabbits, and so this is a completely different geographic area. And so what we saw in that area was there was more rabbits than anything else, and so our model got really good at detecting rabbits and also rocks that look like rabbits and kangaroos that look like rabbits. And then what we found is then when we moved from that one geographic location to the other, what actually happened is that in the second location that we were just talking about then, there was more kangaroos and wallaroos and wallabies than any other species. So it got really good at then seeing that everything was, or thinking that everything was a kangaroo or a macropod, I think is the correct name. And so what we had is there's an imbalance in the training data, which is what we were using. And so then we had to sort of shift we went from everything was almost a rabbit to kind of a little bit rabbity and a lot of kangaroos to lots of kangaroos. And then we've got, more examples in our training set now of wombats and foxes, deer. We even had some flying foxes. And I think there was a frog in there as well, plus something in a tree, which we think was a possum. And so what we found is that it was really, depending on the data we fed into the model, you would get inherent biases just based on the number of examples of a particular species. So we had to start really thinking about how do we construct that data set to get the best result out of the model. And it's quite tricky because lots of times you think, oh, well, more data is better. And in both of these examples, the more data we had, the more rabbits we had in the first instance and the more kangaroos we had in the second. Right. And that didn't actually help us with the accuracy of our model. So it's, to your point about fairness.
Such a great example how bias can easily creep in, and the point that Drew makes about more data is not necessarily great. Sometimes you need just as many of the minority so that the model can see or determine between the two. A great, and macropods and whether it's a rabbit or a kangaroo or something is a bit of a funny example, but the reality is that those kind of biases can have real effects. And Mark and I were talking about one recently where, during COVID, a clever company worked out a hand sanitizing device that you put your hand under there and it scans your hand. It recognizes a hand and provides a small dosage of hand sanitizer. And it worked really well until people of a different ethnicity to all of the white Caucasian developers put their hand under the thing, and it didn't work because it just simply the training data didn't have enough examples of other ethnicities, and it just didn't work. But that's a real world problem of how a small little bias can slip through the cracks and really create a situation of where there is a lack of fairness.
Yeah. Oh, I think there's so many examples, and I think we'll probably circle back in another episode to dig into that kind of like error classification process, and understanding how data selection is a really important part of addressing bias and fairness, and also how we detect bias in a system. But it's definitely an important part of that risk assessment to understand, what the possibilities are for bias, or what the impacts might be if the system was unfair. The other few things I want to just quickly touch on, and they might not apply as much in this particular case with feral animals, but they definitely apply in other situations. So things like privacy and security. So sometimes we're collecting information that might be sensitive area. Certainly there's at least one project that I was I don't think it was necessarily a planned project that was actually going to get off the ground, but there was an interest in tracking or detecting unfenced pools in a council area, because obviously there's a risk. There's a certain number of children, drown in backyard pools that are unfenced, and sometimes these are, just like a blow-up pool or something like that might still be unsafe, or people will install pools unsafely. So there was at one point in time a suggestion, what if we use drones to try and detect, unfenced pools in people's backyards? But there's a really obvious and immediate privacy issue with like doing surveillance over the community, collecting footage of people's backyards. So that kind of puts that whole solution in the too risky or non-compliant sort of basket. So maybe less of an issue in this particular instance, but there still could be issues if you're doing surveillance close to people's houses or something like that. I'm not quite sure.
Yeah, definitely. I mean, certainly the privacy always comes into the picture when you're playing with drones, like our project is. Less of an issue in the rural areas, but definitely. I think you were mentioning that some of those 5 categories. So for our listeners, we talked about community benefit, we talked about fairness, and we just had a little bit of talk about privacy and security. I think one of the ones that leaves 2 more. So that's transparency and accountability. On the transparency side, I think, again, our Feral AI project, the examples we've given, you wouldn't think that there's much in it, but the same project has applications in things like detection of brumbies in the high country. And that's a really, really politically charged issue, and people have some very, very strong views on the matter. And, the decision that the government makes whether or not to undertake a cull depends very much so on having the right or how many numbers are in the high country. And if you can't give a good, accurate estimate of that population, then you lose a lot of trust. So the relationship between transparency about how the model works, what it's doing, why it's there, and what its limitations are, has a big impact on trust of the AI and the model. Simultaneously, the performance, again, does have a little bit of a play on that trust of a model, but transparency is really the key, so people understand if it doesn't perform, they know why and how. For certain things, does it matter that it has a slight bias towards rabbits over kangaroos when they're both, animals that we need to detect? Maybe not. Sometimes it might. So that's a big one. On the accountability one, that's something that's when we talk about accountability, I think that one's a really good one as well. And that's exactly what we were talking about with having a human in the loop. So pest eradication, if an action's taken to eradicate a pest, and who's accountable for that action? Is it the person that's in the loop, or is it the machine?
Yeah, I was just going to say with the transparency too, I think it's probably in both of these examples we're talking about, and I think it's becoming more sort of, I say popular, but actually more demanded, is the ability to share the data that was used to create the model. Now, sometimes that's not, possible, but I think in this case where we're undertaking a population survey, our view is like if there was a question over the number of animals that we saw and the types of animals we saw, we're like, well, here's the data, here's all the photos that we analysed, and here's the results we had. And if you wanted to spend the 24 hours watching all of the video back, or looking through the 20,000 images that we captured, that's okay. Fill your boots. And I think that we're seeing, and in particular, I think even with the LLMs and all the sort of things that are in the mainstream media at the moment, there's that question about, well, where did the data come from? What's the provenance of it? And how do I establish trust there? So I think going forward, we're going to see more questions. It's not going to be enough to say, here's my model and here's the result. it'll be, here's my model, here's the result, and here's a sample or access to the data or some sort of provenance over the data set that was used to get that. Because, you know, otherwise, how do you trust it? It's like, oh, I asked the computer said yes, no. So I think that's going to be an area which we're going to see lots of activity in.
Yeah, for sure. I mean, an analogy that springs to my mind, it's a bit like, you know, wanting to be sure if someone claims that they're, you know, have a particular qualification, understanding, well, what institution did they study at? You know, is there, you know, medical license one that they just ordered on eBay or something, or did they actually go to med school? And which university was that? Is it something that's approved? So sort of not dissimilar in a way. If there's an AI that's helping us to make some decisions, we want to know, you know, how was it trained? Was that trained in a reliable way? And yeah, and ultimately there is a human who's accountable for any actions coming out of the use of that AI. It's not that, you know, computer says no or computer says yes.
Yeah, I think it's really important to understand that there's always, you know, pluses on minuses on every case, and it's a bit like the live versus the operational versus the non-operational. It's just because it's one doesn't mean that it's bad. And so just because the AI doesn't have a human that's accountable in the decision-making process doesn't mean it's bad. It just means you need to consider how you validate that model and whether or not that matters. You know, if there's a human in the loop that tells you whether or not the bus is going to be on time, you know, like it's less of an issue as opposed to if you know, if it makes a decision with high consequences. The same thing goes with transparency. Look at, you know, some of the large language models, you know, ChatGPT, etc. You know, if people understand that it is capable of, you know, making up a few little, having a little bit of poetic license, and that it's difficult for it to verify where it got that information, then you take that information with a dose of salts. And as long as you're transparent about that, people are okay and they will understand the limits of it. If it's really important to understand the provenance, then you need to hone in on it. But just because it can't give you provenance doesn't necessarily mean it's a bad thing. So it comes back to understand the problem, understand the consequence of those risks.
Yeah, absolutely. I think, you know, we're probably out of time for this conversation, but we'll circle back with another slice of this process where we really look at that kind of like risk rating and the kind of risks that come out of an assessment like this, and how that leads into various mitigations. Some of those mitigations might be things that we do as part of like the validation of the model's performance, where we need to really understand what its limits are, how well it handles certain kinds of edge cases or certain kinds of errors, and establishing like a certain threshold of performance that's acceptable. But some of the other mitigations that need to be put in place are things like, well, how are we protecting data in terms of privacy, or how are we monitoring that the performance of that model once it's actually being, you know, put into production. So depending on where the risk is and what it looks like, there could be a number of different risk mitigations that we might need to take. Some of them might be purely, you know, human operational, or how is this used? Where is it used? What can we use it for? And we're seeing that come out now with quite a lot of state and federal government guidance for like public servants about how they can use large language models, what they can use them for, what they can't use them for. It's not really making any changes to what those large language models can do. It's really just saying, yeah, this is an acceptable use for this particular piece of technology. So so we'll sort of circle back to dig into that another day. But yeah, thanks guys. Any other thoughts or comments before we sign off?
No, I think
No.
it's been a good chat, and there's plenty more content there to dive into. So yeah, thanks for
Yeah.
that.
Pleasure to be
Awesome.
on.
No worries. Well, thanks for your time, and we'll look forward to a follow up. All
Yeah,
the best.
sounds good.
Don't go falling down any wombat holes or crashing any drones when you're running around in the dark there.
Yeah, so well, we can't promise those things, but we'll try not to.
All right. Catch you
Excellent.
later, guys. Thanks so much.
Cheers, guys.
Cheers.